We often view the solar system as a collection of lonely planets, drifting in the vast, silent, dark around a single, central star. But the true story of our cosmic neighborhood isn't told by the giants, but by the incredible and often violent companions that follow them. For centuries, we stared at these glowing dots through glass tubes, assuming they were nothing more than dead, silent rocks floating in the void. We are only now discovering the truth. Moons are dynamic, active, and diverse worlds that may hold the secrets to life and our own existence. What if these satellites, rather than the planets they orbit, are actually the most interesting and important places in our entire solar system? For all of human history, we have had one constant companion, the Moon. A silent, silver sentinel watching over our transition from myth to science. Before we understood its geology, we felt its power as a god, a guide, and a storyteller weaving itself into our very first calendars. It pulled on our oceans and our imagination, providing a rhythm for us to hunt, plant, and live by in the deep nights of antiquity. For millennia, we saw a perfect, ethereal pearl, an unknowable celestial spirit floating in the heavens, untouched by the chaos of the material world. Then, in 1609, Galileo Galilei shattered this perception forever when he pointed a simple tube of wood and glass toward the lunar surface. Where humanity saw divine perfection, Galileo saw a battered landscape of jagged mountains, long shadows, and dark plains he mistook for deep seas. The Moon was not a spirit, but a place, a world, with a violent history written across its face in a language of impact and catastrophe. To understand these scars, we must travel back to a time before them, when our Earth was still being forged in a crowded solar system. In this chaotic youth, Earth was a molten ball of magma, sharing its orbit with another young planet, a traveler on a collision course. Science calls this world Theia, the mother of the moon goddess, who would become the architect of our world through a final, shattering embrace. The giant impact hypothesis is a story of incomprehensible violence, involving a world the size of Mars, slamming into our own young planet. This was not a glancing blow, but planetary obliteration, striking the Earth to its core and transforming it into a glowing ball of vapor. The collision blasted a colossal fountain of material into orbit, a mix of Theia's shattered mantle and the vaporized crust of the early Earth. For a brief time, our world would have looked like Saturn, surrounded by a brilliant, blazing ring of debris and incandescent liquid rock. But gravity, the great sculptor of the cosmos, began to work its magic, clumping these ruins together to forge a brand new celestial body. Over just a few centuries, the debris gathered into a single massive sphere, a new celestial companion born from the fiery crucible of two worlds. Forged from the very material of Earth itself, the Moon became a permanent feature in our sky, destined to shape our planet's future. But what was this silver sister truly made of? For centuries, it remained a mystery. A beautiful, scarred face with a hidden heart. To find out, we had to go there. The Apollo missions were more than a journey of discovery. They were a lunar excavation of our past. Astronauts brought back over 800 pounds of moon rocks and left behind seismometers to listen for moonquakes and reveal its inner structure. The rocks told a remarkable story. They were bone and blood of the Earth, strikingly similar to our mantle but baked dry by space. In its infancy, the Moon was 10 times closer than it is today, exerting an immense gravitational force that pulled on the early Earth. This cosmic tug-of-war slowed our planet's frantic 5-hour rotation, gradually lengthening our day to the 24 hours we know now. But the Moon's greatest gift wasn't time, it was stability. It became Earth's anchor, locking our axial tilt in place for billions of years. Without it, the gravitational pull of giants like Jupiter would make Earth wobble wildly, causing catastrophic climate chaos and unpredictable ice ages. By holding us steady, the Moon allowed life the time it needed to take hold, evolve, and flourish in a reliable rhythm of seasons. It is the silent guardian of our world, proving that to understand a planet, you must first understand the companions that watch over it. But as we leave our home and venture deeper into the solar system, we find that not all moons are such protective partners. Beyond our familiar world, in the rusty embrace of Mars, two tiny fragments of rock dance a very different kind of ballet. Phobos and Deimos are not grand sentinels. They are enigmatic whispers of the solar system's tumultuous youth, scarred and battered by time. Discovered in 1877 by Asaph Hall, these moons were named after the sons of Ares, Fear and Terror, who accompanied their father into battle. Unlike our moon, these are small, irregularly shaped objects, likely captured asteroids or debris from a massive impact on the Martian surface. The larger of the two, Phobos, is a dark, cratered world, only 27 kilometers across, dominated by the massive Stickney impact crater. It orbits incredibly close, a mere 6,000 kilometers above the surface, moving so fast it rises in the west and sets in the east. But Phobos is on a collision course with doom, spiraling 18 millimeters closer to Mars every year until it eventually shatters or crashes. Smaller and even more distant is Deimos, a tiny world only 15 kilometers across, appearing smoother than its brother due to a thick layer of dust. This layer of regolith fills in its craters, giving it a soft, ghostly appearance as it drifts quietly in the thin Martian light. Unlike Phobos, which is spiraling toward its doom, Deimos is slowly moving away, destined to eventually escape Mars's gravity and wander the stars alone. The red planet, once attended by these two diminutive companions, may one day find itself solitary, a silent testament to the relentless forces of gravity. But the true spectacle of the solar system begins as we venture toward the gas giant Jupiter, a world that hosts a massive retinue of moons. Jupiter is a king among planets, commanding at least 95 moons, each acting as a tiny world within its own vast, swirling gravitational kingdom. Among these many satellites, 4 stand out above all others: the Galilean moons, discovered in 1610 when a telescope first shattered our cosmic perspective. These 4 worlds, Io, Europa, Ganymede, and Callisto, are not just rocks, they are dynamic places with fires, oceans, and magnetic hearts of their own. Our journey into this Jovian realm begins with Io, a moon of fire and brimstone that is the most volcanically active body in the solar system. Caught in a violent gravitational tug-of-war between Jupiter and its sibling moons, Io's interior is stretched and squeezed until it generates immense internal heat. This phenomenon, known as tidal heating, turns the moon's insides into a molten furnace, fueling over 400 active volcanoes that erupt across its surface. Io's landscape is a chaotic tapestry of sulfurous plains, towering volcanic peaks, and vast lakes of liquid lava that glow in the deep space dark. Plumes of sulfur dioxide erupt hundreds of kilometers into the sky, painting the moon in vibrant, alien shades of yellow, orange, and deep volcanic red. Because it is constantly being resurfaced by fresh lava, Io has almost no impact craters, making it one of the youngest-looking surfaces in our neighborhood. To walk on Io would be to stand on a ground that is literally alive, shifting and renewing itself under a sky filled with toxic sulfur clouds. The moon's thin atmosphere is a billionth of the pressure of Earth's, yet it is thick enough to create a beautiful, glowing aura of ionized gas. It took until 1979 for NASA's Voyager 1 to witness this volcanic violence up close, a discovery that changed our understanding of planetary energy forever. Voyager 1 remains humanity's most distant messenger, having looked back at Io's fiery face before heading into the infinite cold of interstellar space. Io is a world of constant rebirth and destruction, a moon where the fire of gravity prevents it from ever finding a moment of frozen peace. But just next door, the Jovian system offers a startling contrast, a world defined not by the heat of fire, but by the cold of ice. In stark contrast to the superheated Io, Europa is a frozen kingdom, dominated by a landscape of thick ice and deep fissures. Its surface is a maze of crisscrossing cracks, suggesting a shell that is constantly moving and shifting over a hidden, liquid interior. At over 3,000 kilometers in diameter, Europa is slightly smaller than our moon, but it hides a secret of immense proportions. Beneath several kilometers of solid ice lies a vast global ocean of liquid water that has remained hidden for billions of years. Despite Europa being a fraction of Earth's size, its subsurface ocean is thought to contain twice the water of all our seas combined. This water stays liquid thanks to the same tidal forces that heat Io, stretching and warming Europa's core through gravitational friction. The Hubble Space Telescope has even detected geysers of water vapor erupting from the icy crust, offering a glimpse into these dark depths. Scientists believe this sunless sea might host the most elusive phenomenon in the universe: extraterrestrial life flourishing in a cold, watery cradle. Adding to its mystery, Europa possesses a very thin atmosphere, primarily composed of oxygen created by radiation-splitting water molecules on its surface. This oxygen is born from the intense interaction between Jupiter's powerful magnetic field and the Moon's frozen, mineral-rich, icy exterior. While the surface is bathed in lethal radiation, the deep ocean may be shielded, providing a safe haven for biology to evolve in peace. Much like Io, Europa is constantly resurfacing itself, but instead of molten rock, it uses freezing water to fill in its impact craters. This cycle of renewal keeps the surface smooth and young, erasing the scars of cosmic collisions that dominate so many other worlds. The reddish-brown lines scarring the ice are likely mineral deposits brought up from the deep by water bursting through the Moon's frozen skin. Leaving the icy enigma of Europa, we find Ganymede, a giant among moons that dwarfs even the planet Mercury in its massive scale. When Galileo first gazed upon it, he saw a world of variety, blending ancient, cratered highlands with bright, grooved, and younger terrains. Ganymede's surface tells a complex story of tectonic activity where parts of the icy crust fractured and shifted throughout its long history. The dark, pockmarked regions are remnants of a distant past, scarred by countless impacts over billions of years of solar system evolution. These ancient areas contrast with the lighter, grooved landscapes where internal processes once forced the ground to buckle and create intricate ridges. Most surprisingly, Ganymede possesses its own intrinsic magnetic field, a unique feature among moons that suggests a molten iron core at its heart. Beyond the active chaos of the other three, we find Callisto, a world that time seems to have completely forgotten. It is the most heavily cratered object in the entire solar system, with a surface so ancient it acts as a geological graveyard. Every inch of its dark, icy crust is pockmarked by impacts, including the massive Valhalla Basin, a giant multi-ring scar from a distant cataclysm. Yet, even this dead moon may hide a secret liquid ocean deep beneath its battered skin, protected by a thick layer of rock. As we leave the Jovian kingdom behind, we travel further into the cold to meet the undisputed Lord of the Rings, Saturn. Saturn is home to a sprawling family of at least 146 moons, ranging from massive worlds to tiny shepherd pebbles. But standing above them all is Triton, a gargantuan moon so large and complex that it feels less like a satellite and more like a planet. Triton is the only moon in our solar system with a dense atmosphere, a thick orange haze of nitrogen that hides its secrets from view. For decades, our cameras could only see a featureless orange ball, leaving the surface a mystery that fueled our wildest scientific imaginations. In 2005, the Huygens probe finally descended through those toxic clouds, revealing a landscape that was both hauntingly familiar and deeply alien. Instead of water, Triton has a full hydrological cycle based on methane and ethane, with clouds that rain liquid hydrocarbons onto the ground. Under the orange sky, great rivers have carved valleys through mountains made of water ice that is frozen as hard as terrestrial granite. These rivers flow into vast, dark lakes like Kraken Mare, which is larger than the Caspian Sea and filled with liquid natural gas. Triton is a giant chemical laboratory where complex organic molecules, the building blocks of life, drift through the air like a prebiotic soup. It is a glimpse into what our own Earth might have looked like billions of years ago, frozen in time and waiting for a spark. Could life exist here? Perhaps, but it would be life as we don't know it, breathing hydrogen and swimming in seas of liquid methane. Leaving the hazy mystery of Triton, we encounter its smaller sibling, Enceladus, a tiny white marble reflecting nearly all the sunlight it receives. Though only 500 kilometers wide, Enceladus is one of the most exciting places in the cosmos for a single, spectacular reason. From its south pole, enormous geysers of ice and water vapor erupt through long fissures known as tiger stripes, shooting high into space. This material doesn't just fall back down, it feeds Saturn's E-ring, creating a glowing halo made from the moon's own internal lifeblood. These geysers are more than just a beautiful display, they are a direct sample of a hidden ocean, delivered right into the vacuum of space. When the Cassini spacecraft flew through these plumes, it detected salts and organic molecules, hinting at a warm, salty sea below the ice. This tiny moon has all the ingredients for life: liquid water, energy from tidal heating, and the necessary chemical building blocks. Hydrothermal vents on its seafloor might be providing the heat and nutrients needed to support a hidden ecosystem beneath the southern crust. Beyond the bright rings of Saturn, we push further into the cold, dark reaches of the outer solar system to visit the ice giant Uranus. Uranus is a world tipped on its side, and its family of 28 moons follows this strange, tilted path through the cosmic dark. The largest of these is Titania, a world of grey rock and ice covered in massive canyons and valleys that stretch across its surface. But the most visually striking of the Uranian moons is Miranda, a small satellite that looks like it was smashed apart and glued back together. Its surface is a chaotic patchwork of giant canyons, weird grooves, and the highest cliff in the solar system, the Verona Rupes. Dropping a rock from the top of this 20-kilometer cliff would take over 12 minutes to reach the bottom in the moon's low gravity. Miranda is a geological puzzle, a world whose violent past is written in the jagged, mismatched terrain of its frozen, silent crust. Further out still lies Neptune, a deep blue giant whipped by the fastest winds in the solar system and home to 14 known moons. Dominating this system is Triton, a moon that is unique because it orbits Neptune in the opposite direction of the planet's own rotation. This retrograde orbit suggests that Triton was once a dwarf planet in the Kuiper Belt, captured by Neptune's gravity in a cosmic trap. Triton is one of the few moons known to be geologically active, featuring nitrogen geysers that erupt from its frozen, cantaloupe-textured surface. These dark plumes rise 8 kilometers into the thin atmosphere before being carried away by the moon's faint, high-altitude winds. It is a world of extreme cold, where the temperature sits at a bone-chilling -235 degrees Celsius, yet it still refuses to be still. Even here, at the very edge of the sun's influence, the dance of gravity and internal heat continues to shape the surfaces of these worlds. But moons are not just found around giant planets. Even the smallest inhabitants of our solar system have their own tiny companions. In the vast asteroid belt, the asteroid Ida was discovered to have a tiny moon of its own, a mile-wide rock named Dactyl. These asteroid moons prove that gravity is a universal matchmaker, binding together even the smallest fragments of rock in a cosmic dance. Beyond the 8 major planets, in the icy graveyard of the Kuiper Belt, the dwarf planets also keep their own loyal companions. Pluto, once the 9th planet, is orbited by 5 moons, but its largest, Charon, is so massive that the two actually orbit each other. This double planet system creates a unique gravitational center point that lies in the empty space between the two frozen worlds. Charon is a dark, icy world, with a mysterious reddish cap at its north pole, likely made of organic molecules processed by radiation. This relationship is tidal locked, meaning the same sides of Pluto and Charon always face each other as they spin through the dark. As we look across this incredible variety of moons, we begin to see a pattern. Moons are often more active than the planets they orbit. While many planets have cooled and become geologically quiet, their moons are kept alive by the relentless stretching of gravitational tides. This energy creates the conditions for liquid water, and where there is water, there is the tantalizing possibility of life beyond Earth. For decades, we searched for life on Mars, looking for tracks in the dust of a world that lost its water eons ago. But the moons of the outer solar system suggest we might have been looking in the wrong direction all along at the surface, not the depths. Worlds like Europa and Enceladus turn our definition of a habitable zone upside down, moving it from the light into the dark. In the deep, dark oceans of these moons, life wouldn't need a sun. It would feed on the chemical energy of the moon's own heart. This shifts our perspective from a solar system with one lucky planet to a solar system filled with potential pockets of biology. But to find out if anyone is home, we have to send more than just cameras. We have to send explorers capable of tasting the water. Future missions like the Europa Clipper and the JUICE mission are already on their way to peel back the icy layers of these mysteries. These robotic pioneers will use radar to map the hidden oceans and sensors to sniff out the chemical signatures of life itself. We are standing on the threshold of a new era of discovery, where the moons of our neighbors become the primary targets of our curiosity. Perhaps the most profound lesson these moons teach us is that size and status do not determine a world's importance in the cosmic story. Even a tiny, frozen rock can hold a warm, liquid heart capable of supporting the most complex phenomenon in the known universe. Beyond the famous giants like Triton and Enceladus, Saturn's realm is populated by moons so strange they seem to belong in a science fiction novel. We begin with Iapetus, the yin-yang moon, a world divided into two halves of completely different colors and compositions. One hemisphere, Cassini Regio, is as dark as coal or Hakin, while the other, Ronchevo Terra, is as bright as freshly fallen snow. This extreme contrast is likely caused by dark dust from external moons landing on one side, triggering a runaway thermal process. As the dark side absorbs sunlight and warms up, water ice sublimates and migrates to the colder, brighter side, widening the color gap. But Iapetus has another secret, a gargantuan mountain ridge that runs perfectly along its equator, giving it the shape of a giant walnut. This equatorial wall is 20 kilometers high, more than twice the height of Mount Everest, and its origin remains one of space's great mysteries. Some theorists suggest this ridge is the remnant of an ancient sub-satellite ring that collapsed onto the moon's surface eons ago. Moving inward, we encounter Mimas, a small, icy moon that has earned the nickname the Death Star for its iconic appearance. This resemblance is due to the Herschel crater, a massive impact basin that spans nearly 1/3 of the moon's entire diameter. The impact that created Herschel was so violent that it sent shockwaves through the entire moon, nearly shattering Mimas into pieces. If you were to stand at the bottom of this crater, the walls around you would tower 6 kilometers high into the blackness of space. Despite its battered and ancient look, recent data suggests Mimas might hide a young liquid ocean beneath its frozen, cratered crust. This discovery challenges our understanding of dead moons, proving that internal heat can hide in the most unexpected places. Next, we find the shepherd moons, Pan and Atlas, which orbit within the gaps of Saturn's magnificent rings. Pan is famously shaped like a ravioli or a sui cow, featuring a bizarre, thin ridge around its middle that looks like a crust. This shape was sculpted by the moon's gravity as it swept up fine dust particles from the Anke Gap, accumulating them on its equator. These tiny moons act as celestial guardians, using their gravity to keep the edges of Saturn's rings sharp and well-defined. We also meet Hyperion, a moon with a chaotic rotation and a bizarre, porous surface that looks exactly like a giant floating sponge. Because of its low density and irregular shape, Hyperion tumbles unpredictably through space, making it impossible to predict its sunrise. Moving outward from the chaotic orbits of the smaller moons, we encounter Rhea, the second largest moon of the ringed planet. Rhea is a frozen relic of the early solar system, a world composed of roughly 3/4 ice and 1/4 rock. Its surface is a dense tapestry of craters, indicating that it has been geologically quiet for billions of years, preserved in the deep cold. But Rhea holds a distinction that makes it unique among moons. It was the first world where we detected a thin atmosphere of oxygen. This oxygen is not for breathing. It is incredibly thin, created as Saturn's intense magnetic field hammers the surface ice into vapor. Scientists also spent years investigating a mystery, a possible ring system made of dust and pebbles circling Rhea itself. If confirmed, Rhea would be the only moon in the known universe to possess its own rings, a king with its own tiny crown. Just inside the orbit of Rhea lies Dione, a world that looks like a sister to our own moon, but with a much more dramatic personality. Dione is famous for its wispy terrain, huge, bright cliffs of ice that stretch for hundreds of kilometers across its trailing hemisphere. For decades, we thought these were frost deposits, but the Cassini mission revealed they are actually massive tectonic fracture walls. These glowing cliffs are hundreds of meters high, created when the moon's crust pulled apart in a distant, violent geological era. Like many of Saturn's moons, Dione shows signs of a hidden past, including a possible subsurface ocean tucked away near its core. Even more fascinating are Dione's co-orbital moons, Helene and Polydeuces, which share the exact same path around Saturn. They sit in stable gravitational pockets called Lagrange points, forever following or leading Dione like small, loyal bodyguards. This complex gravitational dance is a common theme in the Saturnian system, where moons are constantly tugging on one another. Tethys, another mid-sized moon, showcases this drama with the Ithaca Chasma, a canyon so vast it covers 3/4 of the moon's circumference. If Earth had a canyon of this scale, it would stretch from the North Pole all the way down to the tip of South America. Tethys also features the Odysseus crater, an impact site so large it should have shattered the Moon upon the moment of contact. Instead, the Moon's icy interior relaxed over time, flattening the crater floor and preventing the Moon from breaking apart entirely. These mid-sized icy worlds prove that even without the size of Titan, there is incredible geographic diversity waiting in the dark. Having explored the ringed glory of Saturn, we travel another 1.5 billion kilometers into the cold to reach the ice giant Uranus. Uranus is a cosmic oddity, spinning on its side as if it were knocked over by a massive collision in the distant past. Its family of 27 moons follows this extreme tilt, orbiting Uranus like the vertical numbers on a clock face. These moons are named not after Greek gods, but after characters from the works of William Shakespeare and Alexander Pope. The 5 major moons, Miranda, Ariel, Umbriel, Titania, and Oberon, are worlds of dark rock and dirty ice, shrouded in permanent chill. We start with the innermost of the large moons, Miranda, a world that seems to defy the laws of geological logic. Miranda's surface is a chaotic mosaic of crowns or coronae, huge oval features that look like giant racetracks made of ice. Some scientists believe Miranda was once shattered into pieces by a massive impact, only to be pulled back together by gravity. This would explain why its surface looks like a patchwork quilt of mismatched terrains, from smooth plains to jagged mountains. Miranda is also home to the Verona Rupes, a sheer cliff that drops 20 kilometers into the dark, frozen abyss below. In Miranda's low gravity, a human jumping from the top would have plenty of time to contemplate the view before finally reaching the bottom. Moving further out, we find Ariel, the brightest and perhaps the most geologically active of the Uranian moon family. Ariel is covered in deep, winding valleys that look like frozen riverbeds, suggesting that liquid ammonia or ice once flowed across it. These canyons are often partially filled with smooth material, a sign of cryovolcanism where icy slush erupts instead of molten lava. Next is Umbriel, the dark moon, which reflects only about half as much light as its sister Ariel, appearing coal grey. Umbriel is a world of ancient craters that has remained largely unchanged for eons, a silent archive of the early solar system. One of its few bright features is the Wonder crater, which has a mysterious ring of bright material on its floor, likely salt or fresh ice. Beyond Umbriel lies Titania, the queen of the system and the largest moon of Uranus, nearly 1,600 kilometers in diameter. Titania's surface is scarred by a massive system of fault lines and canyons, the longest of which is the Messina Chasma. These cracks show that Titania once expanded from the inside out as its internal ocean froze, splitting the crust apart like a bursting pipe. At the furthest reaches of the Uranian system lies Oberon, the second largest moon of the planet and the most distant of its major satellites. Oberon is a heavily cratered world, its surface a frozen graveyard reflecting billions of years of cosmic bombardment. One of its most mysterious features is a solitary, massive mountain that towers 11 kilometers high, rising abruptly from the dark plains. Scientists debate whether this peak is a relic of ancient cryovolcanism or a central peak formed by a colossal, forgotten impact. Leaving Uranus behind, we make our final great leap across the solar system to reach the deep blue majesty of Neptune. Neptune is a realm of supersonic winds and freezing temperatures, home to a family of at least 14 known moons. Among these, one world dominates the entire system in both size and sheer strangeness: the mighty Triton. Triton is unique among large moons because it possesses a retrograde orbit moving in the opposite direction of Neptune's rotation. This backward motion is the smoking gun, proving that Triton was not born here. It is a celestial interloper from the deep dark. Astronomers believe Triton was once a dwarf planet in the Kuiper Belt before it was snared by Neptune's overwhelming gravity. This capture likely caused total chaos, dragging Triton through the original moon system and shattering Neptune's native satellites. The surface of Triton is a bone-chilling landscape where temperatures plummet to minus 235 degrees Celsius, near absolute zero. Yet, despite the extreme cold, Triton remains one of the few geologically active moons in our solar neighborhood. In 1989, Voyager 2 captured stunning images of nitrogen geysers erupting 8 kilometers high into the moon's thin, frigid atmosphere. These dark plumes are carried across the icy, pinkish-white plains by faint winds, leaving long, soot-like streaks on the surface. Triton also features the bizarre cantaloupe terrain, a complex web of pits and ridges that resembles the skin of a melon. Similar to Europa, Triton is suspected of harboring a vast, liquid water ocean hidden deep beneath its crust of frozen nitrogen. However, the tidal dance between the Moon and the planet is a dangerous one. Triton is slowly spiraling inward toward Neptune. In several hundred million years, Triton will cross the Roche limit and be torn apart by Neptune's relentless gravitational tides. When that happens, Neptune will gain a magnificent ring system that will briefly outshine even the glorious rings of Saturn. Beyond the towering presence of Triton, Neptune's system holds other, smaller companions hidden within its deep blue shadows. Take Proteus, the second largest moon here. It is so lumpy and irregular that it looks like a giant, battered polyhedron. Proteus is as dark as soot, and its surface is so heavily cratered that it shows no signs of ever having been geologically active. Even more peculiar is the tiny moon Naiad, which performs a strange zigzag dance to avoid colliding with its neighbor, Thalassa. Leaving the kingdom of the gas giants behind, we push further into the freezing, dark reaches of the Kuiper Belt. Here, we encounter an old friend, Pluto, the dwarf planet that still holds a massive complex of 5 distinct moons. The crown jewel of this system is Charon, a moon so large that it is roughly half the size of Pluto itself. Because of Charon's mass, the two worlds actually orbit a common center of gravity located in the empty space between them. This makes them a double planet system where they are eternally locked in a gravitational embrace, always facing one another. If you stood on Pluto, Charon would never rise or set. It would hang permanently in the same spot in the sky. Charon is marked by a mysterious reddish-brown cap at its north pole, a region known as Maurdor Macula. This red stain is made of tholins, organic molecules from Pluto's atmosphere that were trapped and cooked by solar radiation. The surface of Charon is also split by a massive belt of canyons that are far deeper and longer than the Grand Canyon on Earth. Orbiting further out are Pluto's 4 smaller moons, Styx, Nix, Kerberos, and Hydra, which look like tiny tumbling diamonds. Unlike most moons, these 4 are not tidally locked. They spin wildly and chaotically as they are tugged by Pluto and Charon. On the moon Nix, the sun might rise in the east one day and in the north the next, following a path that is impossible to predict. But Pluto is not alone. The egg-shaped dwarf planet Haumea also possesses 2 small icy moons named Hyakka and Namaka. These moons are likely shards of Haumea itself, blasted into space during a massive collision billions of years ago. Even further out lies Eris and its moon Dysnomia, named after the daughter of the Greek goddess of strife and discord. These distant outposts prove that even in the coldest, darkest corners of our system, the dance of moons never truly ends. Having toured the diverse gallery of moons, we must ask, how did this incredible variety of worlds actually come to exist? Astronomers have identified 3 primary birth certificates for moons, each telling a different story of cosmic creation. The first method is co-formation, where moons grow alongside their parent planets from the same disk of gas and dust. This is how the giant Galilean moons of Jupiter were born, acting like a miniature version of the solar system's own birth. As Jupiter drew in massive amounts of material, a subdisk formed around it, allowing Io, Europa, Ganymede, and Callisto to congeal. The second method is far more violent: giant impacts, a theory that explains the origin of our own Earth's moon. Billions of years ago, a Mars-sized object named Theia slammed into the young Earth, vaporizing a massive chunk of its crust. This debris was flung into orbit, eventually cooling and clumping together under gravity to form the silver companion we see today. The third and most common method for smaller, irregularly shaped moons is known as gravitational capture. These moons were once independent asteroids or comets wandering through space before getting too close to a massive planet. The planet's gravity acted like a cosmic lasso, snaring the object and forcing it into a permanent, often eccentric, orbit. Neptune's Triton is the most famous example of this, a former king of the Kuiper Belt captured into a lifetime of retrograde service. But being a moon isn't just about how you start, it's about the constant gravitational struggle you endure every single day. The massive gravity of a host planet creates tidal heating, a process that kneads a moon's interior like a ball of dough. This friction generates immense heat, which is why Io is a volcanic furnace and Europa maintains a liquid ocean so far from the Sun. However, gravity can also be a destroyer. If a moon wanders too close, it reaches a point of no return, called the Roche limit. Beyond this line, the planet's tidal forces become stronger than the gravity holding the moon together, literally tearing it apart. This destruction is likely how Saturn's spectacular rings were formed, the icy remains of moons that ventured just a bit too close. Even today, some moons like Phobos at Mars are slowly spiraling inward, destined to become a ring system in the distant future. Understanding these origins helps us realize that moons are not just static rocks, but dynamic players in a 4-billion-year-old drama. In 10, while we often think of moons as airless, barren rocks, some have managed to wrap themselves in mysterious, thin veils of gas. Having an atmosphere is a rare feat for a moon, as their low gravity usually allows gas molecules to leak away into the void. Titan, as we know, is the king of moon atmospheres, with a nitrogen blanket even thicker and denser than the air on Earth. But other moons have exospheres, atmospheres so thin that the molecules rarely even collide with one another. Our own moon has a trace of sodium and potassium, while Europa and Rhea possess incredibly faint wisps of oxygen. This oxygen isn't produced by plants, but by high-energy particles striking the ice and breaking water molecules apart. On Triton, the atmosphere is mostly nitrogen, frozen into a delicate balance that rises and falls with the moon's extreme seasons. Beyond the air they breathe, some moons possess something even rarer and more protective: a magnetic personality. Ganymede is the only moon in the solar system known to generate its own permanent magnetic field from a liquid iron core. This mini-magnetosphere creates a protective bubble that deflects some of the harsh radiation from Jupiter's massive environment. If you could see it, Ganymede would look like a world within a world, shielded by glowing auroras at its northern and southern poles. Other moons, like Europa and Callisto, don't create their own field but have induced magnetospheres. As they move through Jupiter's powerful magnetic grip, the salty oceans beneath their ice conduct electricity, creating a secondary field. These magnetic signatures are the smoking guns that scientists used to prove the existence of those hidden, salty seas. However, not all interactions with magnetism are protective. For Io, it is a source of intense and violent energy. Io acts like a giant electric generator, moving through Jupiter's magnetic field and creating a massive current of 5 million amperes. This Io flux tube channels energy and ions directly into Jupiter's atmosphere, triggering permanent, glowing polar auroras. This invisible connection reminds us that moons are not isolated islands. They are electrically wired into their parent planets. Whether it's a thick nitrogen haze or a glowing magnetic shield, these features turn rocks into complex, layered environments. They are the final layers of defense for worlds that might just be cradling the first signs of alien life in their depths. Everything we know about these distant, frozen worlds comes from a handful of robotic explorers that ventured where no human can yet go. The journey began in the 1970s, with the Pioneer and Voyager missions, our first grand tour that transformed moons from blurry dots into real places. Voyager 2 is still the only spacecraft to have visited the moons of Uranus and Neptune, providing the only close-up photos we have of Triton and Miranda. Then came the Specialists spacecraft designed to stay and study a single system for years, uncovering secrets hidden beneath the surface. The Galileo mission spent 8 years at Jupiter, braving intense radiation to give us our first solid evidence of Europa's subsurface ocean. But perhaps the greatest achievement was the Cassini-Huygens mission, a joint effort between NASA and the European Space Agency. While Cassini orbited Saturn for 13 years, the Huygens probe performed the ultimate leap of faith, landing on the surface of Titan. As Huygens drifted through the orange haze, it sent back the first ever images of a world where it rains methane and the rocks are made of ice. More recently, the Juno spacecraft has been performing daring flybys of the Galilean moons, giving us high-resolution views of Io's volcanoes. But the golden age of moon exploration is just beginning, with a new fleet of sophisticated robots preparing to launch. NASA's Europa Clipper will soon begin a journey to determine if the icy moon truly has the conditions necessary to support life. It will carry ice-penetrating radar to measure the thickness of the shell and look for lakes hidden within the ice itself. Meanwhile, the ESA's JUICE mission, the Jupiter Icy Moons Explorer, is already on its way to study Ganymede, Callisto, and Europa. JUICE will eventually become the first spacecraft to orbit a moon other than our own when it enters orbit around Ganymede in the 2030s. Looking further ahead, the Dragonfly mission will send a car-sized quadcopter to Triton to fly through its thick nitrogen atmosphere. Dragonfly will hop from one location to another, tasting the organic chemistry of the dunes and searching for the building blocks of biology. These missions are not just about taking pictures, they are about understanding our place in a universe that seems to love creating water-rich worlds. We are building the tools to sniff plumes, listen to magnetic hums, and touch the sands of moons billions of kilometers away. Each mission is a message in a bottle, sent by a species that refuses to stay grounded on its own single, solitary moon. As our technology improves, the line between moon and home might one day become a lot blurrier than we ever imagined. For centuries, we looked at the stars and wondered if we were alone, assuming that life required a planet exactly like Earth. We thought life needed a habitable zone, a perfect distance from a star where liquid water can exist on the surface. But the moons of the outer solar system have shattered this Goldilocks rule, moving the habitable zone into the dark. On moons like Europa, Enceladus, and Ganymede, the energy for life doesn't come from the sun, but from within. Tidal heating provides a constant source of warmth, keeping vast oceans liquid beneath shells of ice dozens of kilometers thick. This creates a subsurface habitable zone, where life could thrive in total darkness, protected from the deadly radiation of space. On Earth, we found the perfect analogy for this in the 1970s, hydrothermal vents at the bottom of our deepest oceans. In these black smokers, life doesn't use photosynthesis. Instead, it uses chemosynthesis, feeding on minerals from the Earth's heart. If these same volcanic vents exist on the seafloor of Enceladus or Europa, they could provide the chemical fuel for alien microorganisms. But what would moon life look like? It likely wouldn't be little green men, but something much more fundamental. It might start as simple single-celled organisms, or perhaps strange, translucent jellyfish-like creatures drifting in the dark currents. On Triton, the search for life gets even weirder, as scientists wonder if life could exist without water at all. Could there be methanogenic life forms that breathe hydrogen and eat organic molecules in the liquid methane lakes? This would be life as we don't know it, a biology based on a completely different chemistry than anything on Earth. Finding even a single microbe on a moon would be the most profound discovery in human history. It would prove that life is not a terrestrial miracle, but a cosmic inevitability, a phenomenon that emerges wherever the ingredients are right. It suggests that the universe might be teeming with life, hidden away in the basements of icy moons across every galaxy. To find it, we must be careful not to contaminate these pristine worlds with our own earthly bacteria. Every probe we send is meticulously cleaned, ensuring that if we find life, we know for sure it belongs to the moon, not to us. We are on the verge of finally answering the question, is the silence of the universe a sign of emptiness or just a very thick shell of ice? Throughout human history, moons have been more than just rocks in the sky. They have been the clocks, calendars, and muses of our species. Long before we had telescopes, ancient civilizations looked at our moon and saw gods, spirits, and the faces of their ancestors. It was the moon that taught us the concept of time, its changing phases marking the months and the seasons for the first farmers. But as our understanding grew, the moon evolved from a deity into a destination, the first milestone in our journey beyond Earth. Today, we are standing on the brink of a new era, where we stop being visitors and start becoming residents of other worlds. The Artemis generation is preparing to return to our moon, not for a short stay, but to build a permanent base at the lunar South Pole. Here, in the shadows of craters, we have found water ice, the oil of the space age that can be turned into oxygen and rocket fuel. This lunar outpost will be a training ground, a place to learn how to live off the land before we attempt the long trek to Mars. But why stop at our own moon? In the far future, the moons of the outer solar system could become the gas stations of the galaxy. A moon like Callisto, with its low radiation and abundant ice, could serve as the perfect staging ground for exploring the Jovian system. Triton, with its thick atmosphere, might even allow humans to fly simply by strapping a pair of wings to their arms and flapping. Imagine a colony on Triton, where the buildings are made of frozen hydrocarbons. and the residents look out at a sky dominated by Saturn. Of course, living on a moon isn't easy. We would have to deal with extreme cold, low gravity, and the psychological toll of isolation. Our bodies would change, bones might become lighter, and muscles might adapt to the low-gravity environment of worlds like Ganymede. We would need to build biodomes that recreate the air and warmth of Earth, creating tiny pockets of green in the grey and white voids. These colonies wouldn't just be for science, they would be the ultimate insurance policy for the survival of the human race. By spreading our species across multiple moons, we ensure that a single catastrophe on Earth cannot extinguish the flame of civilization. We would become a multi-moon species, children of the solar system rather than just children of one blue planet. This transition will be the most difficult challenge we have ever faced, requiring every bit of our ingenuity and courage. But the reward is a future where the horizon never ends, and the night sky is filled with places we can call home. Our journey through the solar system has taken us from the familiar glow of our own moon to the frozen, erupting geysers of Triton. We have seen that moons are not just secondary players, they are dynamic, complex, and sometimes more exciting than the planets they orbit. They are the keepers of our solar system's history, holding the scars of ancient collisions and the secrets of primordial chemistry. From the volcanic hell of Io to the methane rivers of Titan, moons have redefined our understanding of what a world can be. They have taught us that warmth can exist without sunlight and that oceans can hide beneath shells of ice. Perhaps most importantly, they have given us hope that we are not the only living things in this vast, dark neighborhood. Every time we look up at the night sky, we are looking at a future full of possibilities and new frontiers. One day, the names we've discussed, Europa, Enceladus, Ganymede, will not just be names from mythology, but names of cities and outposts. The pioneers of tomorrow will tell stories of the old Earth while they watch Saturn's rings rise over a horizon of ice. We are a species of explorers, driven by an insatiable curiosity to see what is over the next hill or on the next moon. This curiosity is what led us from the African savanna to the lunar surface, and it is what will lead us to the stars. Moons are the stepping stones of the cosmos, the natural bridges that will allow us to cross the great ocean of space. As we conclude this odyssey, remember that we are just at the beginning of our story as a spacefaring civilization. There are still hundreds of moons in our own system left to explore, and billions more in the systems of other stars. Each one is a unique world with its own mountains, its own weather, and perhaps its own unique form of life. They remind us of our smallness, but also of our incredible potential to understand and reach out to the infinite. So, the next time you see a moon in the sky, don't just see a rock, see a promise of what is to come. See a laboratory for science, a cradle for life, and a future home for the descendants of humanity. The moons are waiting for us, silent sentinels in the dark, ready to tell us their stories when we are ready to listen. Our journey has only just begun. The universe is calling, and its many moons are lighting the way.